However, sometimes when I say that, I see a tremendous amount of disdain on your faces. You'll also notice that I jumped up to chapter 3. For some odd reason, our textbook left this lesson until way in chapter 3, which is redonkulous. We can do it now while we're talking about limits. So the only change today from what we did Tuesday is that on Tuesday we were looking at the behavior around vertical asymptotes, and our answers were usually infinity or negative infinity. Today we're flipping it 90 degrees, and we're looking what happens when you go very far out to infinity. What numerical value do you get? Does that make sense? Does that make sense? Okay, good. Just checking. Okay, so you did anybody? Pig Latin, anybody? Ig pay Attenley? Okay, never mind. So I've got a graph here of a V-looking thing. I don't even know what the function is, but it has a horizontal asymptote of 3. Just for practice, what is the limit as x approaches 0 of that function?
0.
0, good. What is the limit as x approaches 1 of that function? You can approximate. 1.5, somewhere around there. Beautiful. Okay, now what happens if I go very far out to the right? In other words, what happens when x approaches negative infinity? What's it going to get closer and closer to?
3.
Say again?
3.
3, very good. Is that a difficult concept? Good. What happens when I go very far to the left? Negative infinity. 3. By the way, quick review. Can a function cross a horizontal asymptote? Yes. Doesn't usually, but it can. Can it cross a vertical asymptote? No. No, that would give you a 0 denominator. 0 denominator is bad. Okay, so there they are summed up. As x approaches infinity, we get a value of 3. As x approaches negative infinity, we get a value of 3 also. Okay, that's different than what we did Tuesday, because Tuesday it would say something like as x approaches 3, and we would get an answer of positive infinity going up, up and up and up and up. Okay, so here comes your pre-calc review. There are 3 ways that you can generate a horizontal asymptote. And the reason we want the horizontal asymptote is shown in that picture there. If we can figure out the horizontal asymptote, that's going to demonstrate where the function gets very close to as it goes very far away from 0. So, method number 1, or I if you prefer. If the degree of the numerator is less than the degree of the denominator, then the horizontal asymptote is the x-axis. So I'm assuming a lot. I'll check with you. Do you understand what I mean by the degree? Conrad, what's the degree of the numerator in that example?
3. Wait, the numerator is the top one or the bottom? The top one. 2.
Oh, there's a lot to unpack there. Are we good?
Yeah.
2.
2.
Good. Let's see if we can. I don't know what I'm going to do. But Conrad, what's the degree of the denominator?
3.
Well done. Very good. So you can see that it fits into our situation here. The degree of the numerator is less than the degree of the denominator. And therefore, the horizontal asymptote is 0. Y equals 0 or the x-axis. You probably want to get in the habit of referring that to the line y equals 0 so that you don't get those two things confused. Okay? Good? You know this, right? Yeah. Good. Let's move on. Case number 2. If the degree of the numerator matches the degree of the denominator, then you take the ratio of the leading coefficients. Are we okay with the term leading coefficients?
Yep.
Molly, I got a thumbs up from you. What's the leading coefficient in the numerator?
3.
What's the leading coefficient in the denominator?
2.
Outstanding. Therefore, our horizontal asymptote, even though it's not in the picture, would be at 3/2, also known as 1.5. You're all fairly bright. What is case 3?
The degree of the denominator is greater than the degree of the numerator.
Bingo! This is the one nobody likes, because See if you remember from precalculus. What happens when the degree of the numerator is bigger than the degree of the denominator? I'll give you a hint, it's a visual.
You have to do long division.
Yes, and what do you get? What kind of asymptote?
So,
What's that? No?
a line?
No? What are these? These are my obliques, correct? I know, they're so ripped, you can see them right through the shirt. Yeah, the 9-pack I've got under there. Oblique asymptotes. Now hold on a second. Did that come out of you, Smitty?
Maybe.
Okay. We're really not going to have to find the the oblique asymptotes. I'm going to show you a trick to solve these problems. Okay, so looking at that picture, what's going to happen as x gets very, very big? In other words, it goes to infinity. What y value is the function going to approach? Explain. That is correct. Explain.
I mean, visually, it's going to go with, like, as you keep going, right, the slope of it looks like as x increases, it goes up.
Correct. Everybody follow that, because that's an important point. This will save you a lot of hassles if you understand this. Okay, what he said is, the slope is positive, so if you go very far to the right, it continues to get bigger and bigger, so if you go very far to the right, then the y value gets very big, also known as infinity. If you go to the left, the opposite is true. Now, what if I reverse the asymptote? What if it has a negative slope? What if it looks something like this? So what's the limit as x approaches infinity of that puppy? As I go very far to the right, what's happening to the y value? Negative infinity, correct. Is that an okay concept? So the only trick we need then is I just need to know, is the asymptote, the oblique asymptote, going to be positive slope or negative slope? I don't really care what it is. Because notice, is this y equals x? Is it x plus 1? Who cares what it is? All I know is that I go very far out here. This is going to go very high. To do that, it's real simple. When you do long division, and we're not going to review long division, you divide the numerator by the denominator. The first term for us will always be a linear term. You'll get something x. Okay, so if we were to do the long division in this case, I'd take x cubed and I'd divide it by 2x squared minus 1. If I divide x cubed by 2x squared, will I get a positive or a negative answer? Positive. Yeah. Why are we on the struggle bus there? Positive, yes. A positive divided by a positive is positive. So this tells me that I have a positive slope. That's all you need. If you understand these concepts, then the only trick you need to be able to do is find the slope of the oblique asymptote. Very seldomly, if ever, will you be asked to actually find the I meant to do that. Actually find the oblique asymptote. Okay? Make sense? Good. 1 and 2 are the much more common scenarios. Oh, I think I broke it. Not broken. Okay, good. All right, so we did that already. And what that does is it confirms what we've already talked about. The answer to the limit problem is the value of the horizontal asymptote in cases 1 and 2. Case 3 gets a little strange. It would be nice if, we talked about that. It would be nice if that was all you needed to do, but the functions are going to get a little scary. So I want to show you some other techniques to solve these problems. Okay, so for instance, this one, I don't have a rational function. I've got 5 minus 2 over x squared. How are we going to approach that problem? Ideas? Well, what's the first thing you always do? Plug and chug. Plug and chug. Limit as x approaches infinity of 5 minus 2. Oh, what's infinity squared? Infinity. Yeah, there's no infinity.
Wait, isn't it like, if the 5 doesn't even matter because as you get big, it's not really gonna impact the graph? Is that something different?
No, can I come back to your answer, your statement in a second? Let's talk about this puppy here. I've got a fraction. The fraction gets very, very big in the denominator. What happens to the entire fraction?
It's smaller.
How small?
So
Infinity
small?
small.
Infinite.
Think carefully.
Infinity small.
Infinity small?
Infinite.
Infinitely small. So this value then
It's getting
would be
more
negative
positive.
infinity?
But it's getting more positive because it's less negative.
It's getting more positive because it's less negative. That's a true statement. But you're wrong. It doesn't go to negative infinity. What does it get closer and closer to? 0. Very good. Okay. So this would go to 0. And therefore, our answer would be 5. Okay. One way to solve the problem. There are others that I'll cover in a second. Are we good with that? Okay. Now, what happens if I have something like that? First of all, that's bad, icky bad. But we can talk about what happens as the number gets close to 0. As the denominator gets very tiny, what happens to this whole fraction? Okay, so let's say 2 over 10 versus 2 over 3 versus 2 over 2 versus 2 over 0.001. What's that getting closer and closer and closer to?
Infinity.
Infinity. Very good. Okay. Denominator gets very big, the fraction approaches 0. Denominator gets very small, fraction approaches infinity. Okay, so let me get this out of the way, and we'll talk about the different ways to solve this problem. The other way that most of you would choose not to do would be to do some, well, we did that already. Okay, that's the one we talked about. Where's the other one? Here it is. Bingo. Okay, you can do some algebra. Common denominator. Most of you won't choose this, but it is another possibility. Case 1, case 2, or case 3? I did that with my brain.
Her phone's ringing.
Well, answer it.
Me?
Yeah.
It's an unknown name.
Hello. Hi, Matt. I don't need any coverage on my vehicle. Oh, that's not even a real person. Sorry, whoever that was. Whose phone is that, by the way? Did you want coverage for your vehicle? Matt will call back, don't worry. Case 1, case 2, or case 3?
It's case 2.
2, correct. So where's the horizontal asymptote? 5. So therefore the answer is, which is kind of a silly question because we just did it a couple minutes ago, but we get 5. Different way to approach the problem. Okay. Making some sense here. Beautiful. Clickety, clickety. Okay. Here we go. What's the answer? 2. We're good?
Yeah.
We need anything else there? But I'm going to show you a different technique using this as an example. Again, plug and chug first. We get 0, or sorry, that's an infinity. Infinity over infinity. Get some terminology under control. This is called an indeterminate form. This is our second one. The other one is 0 over 0. Okay, there's another technique that you can use. You're not going to use it here because it's too simple. That horizontal asymptote is easy to find. But the other technique involves dividing everything by the largest term in the rational function. Okay, what do I mean by that? In this, the highest term is x. In some of the other ones, clickety, clickety, clickety. This one, for instance, the highest term would be x cubed. And as it gets more complicated, this might be a viable solution method because it turns into something like, where is it? Oh, I don't have it. If I go back to the function, what is it? 2x minus 1 over x plus 1. 2 2x minus 1 over x plus 1, the limit as x approaches infinity. If I divide everything by x, or if you prefer, multiply by 1 over x, this is legal because it equals 1, I get the limit as x approaches infinity of 2 minus 1 over x over 1 plus 1 over x. And again, you wouldn't do it for this easy problem. Based on what we just talked about a couple screens ago, what does that go to? As the denominator gets very big, the fraction goes to 0. What's this go to? It's the same thing, 0. Good, so we get an answer of 2. Now, are you going to use that technique? No. I asked the first question, you didn't skip a beat. Boom, 2. Because of the horizontal asymptote. That's what I would use also. But again, showing you other techniques to find these limits as x gets very big. Okay. Yeah, we said that already too. We're good. Okay, now this guy. What's the answer? 3/4. Degree of the numerator is 2, degree of the denominator is 2. If you divide everything out, though, using that technique, another illustration of that here, 3 minus 3 over x plus 2 over x squared all over 4 minus 7 divided by x squared. Train wreck. But goes to 0, goes to 0, goes to 0, 3/4. Okay. Good? Am I going too fast? No? Okay, so there's what I just did. Not the best approach in the world, but it is a viable way to solve the problem. Horizontal asymptote is probably how you solved it initially. And then the third technique is look at the graph. Notice, I picked this function for a reason, it crosses the horizontal asymptote here. Doesn't matter how many times it crosses the horizontal asymptote, as I go very far out, it's going to get closer and closer to 3/4.
Okay.
Thank you for the acknowledgement. That makes me feel like at least one person's paying attention. Thank you, Molly. Very seldomly, if ever, will I say use this technique to find the answer to the limit problem. Therefore, I want to give you as many things as possible to use, which increases your options for solving a problem like that. I'm guessing that most of you are going to use this technique, the horizontal asymptote technique, which is great. You'll probably have a little bit of struggle during the oblique asymptote problems that come up in the homework, but we can work through that together. Remember, you're just looking for whether it's positive or negative. I'm going really fast, I know, but we don't need to talk about this, right?
No.
Good. There's a picture, in case you care, and we're done.